Welcome to Section 4 on Loops and Iteration. In this section, we are going to learn how to make our programs repeat actions automatically instead of writing the same code again and again. By the end of this module, you'll understand how repetition works in programming, how to write both for and while loops, how to control their behavior, and how to avoid common mistakes. Think about everyday tasks like brushing your teeth, checking attendance, or counting steps. These are all repetitive actions. In programming, loops allow us to represent and automate these kind of repeated behaviors. Loops are powerful because they help us avoid repeating code, work with large amounts of data, automatic process, and make our programs more efficient and scalable. Without loops, we would have to write the same line of code over and over again, which quickly becomes messy and hard to maintain. With loops, we can write it once and let the program handle the repetition for us. What is a loop? A loop is simply a structure that repeats a block of code until a condition is met. You can think of loops as the engine that drives automation in programming. There are two main types of loops. A for loop is used when we know how many times something should run. A while loop is used when we don't know the number of iterations in advance and instead rely on a condition. Every loop has three key parts. Initialization, where we set the starting value. A condition, which determines whether the loop continues. And an update, which changes the value each time. If we forget the update step, the loop can run forever. The logic of a loop follows a cycle. First, the condition is checked. If it's true, the code runs. Then, the variable updates. And then the process repeats. If the condition becomes false, the loop stops. Let's take a simple example, counting from 1 to 5. In Python, we can represent this using a loop with a range that starts at 1 and stops before 6. What is for loop? A for loop is used when the number of iterations is known. It works by going through a sequence, such as a range of numbers, and executing code for each value. For example, when we use range 5, Python generates numbers from 0 to 4. The loop variable takes each of these values one by one. And remember the indentation to define that the code is belonging inside this for loop. As a result, the output shows numbers from 0 to 4 because the range was till 5, demonstrating how the loop progresses step by step. The loop variable, often written as I, is just a temporary placeholder. It simply holds the current value during each iteration and updates automatically. For loops are commonly used for repeating actions a fixed number of times or for iterating through datasets like lists, strings, or collections. The range function is what allows us to control how many times a loop runs. By default, it starts at 0 and stops before the number we specify. So since we have the range 5, it started from 0, 1, 2, 3, 4, then it's stopping before 5. When we provide both a start and stop value, the start is included, but the stop is not. So range 1, 6 produces numbers from 1 to 5. So this is just going to be producing the result showing 1, 2, 3, 4, 5, and 6 will not be included, just like how it was there for the range 5 as well. The range function can also take a step value, which controls how much the number increases each time. This allows us to skip values, such as counting in steps of 2. So for this one, we are having a start, so the beginning number, which is inclusive. Stop is the end number, when the range basically, when it ends, the end limit, which will be excluded. Step, the amount to increment by. So every time it's increasing by 2. So it will be 0, 2, 4, and done. We can also use loops to simulate real-world processes. For example, iterating over time to model something like a battery charging or stepping through specific intervals. So for here, the code is basically just a simple case to show you. For I in range, so 0 is the start, 10 is the end, and 2 is the way it's incrementing. So it will be 0, 2, 4, 6, 8. And it's just to show you the charge simulation, and the value given is for the battery is 50. For our in range 5, so the battery will be plus equals 5. So that means it will simulate charging by adding energy each iteration. So it's going to increase by 5. So here in Python, strings are iterable, which means we can go through each character one at a time using a loop. So strings are iterable sequences. You can access each character one by one. Order is preserved 0 to n. So for character in Python, for example, print character, it will be P for 0th index, and then 1, the first index, second index, third index, fourth index, and fifth index. So the characters, you can access them one by one. The output shows each character printed separately. So this one is going to be showing each character printed separately. So because they are iterable objects, strings are iterable objects. And the loop variable char, this character, automatically takes the value of each character one by one. Here you can see that the output, like I said, is going to be shown character by character, which helps us understand how iteration over strings work. So each character is printed separately. This becomes useful when working with text, for example, when counting characters or searching for specific patterns. So when you're counting letters, for example, you iterate through a string to count the occurrences of specific characters, such as vowels, digits, or symbols. And when you're searching for characters, you scan the string to detect if a specific character is already inside it, find its position, or validate the input format. The accumulator pattern is an important concept. It allows us to keep track of a value that changes during each iteration, such as counting or summing. So the count one is the one that's accumulating because it's increasing by 1 each time. So the count variable acts as an accumulator. It starts at 0 because it's here put at 0 and increments by 1 for every iteration of the loop. So for example, it will be hello, so it will keep iterating 1 time. Lists allow us to store multiple values in a single variable, making it easier to manage and iterate through the data. It's defined using square brackets. This way, the lists organize data for easy iteration. So in this case, it will be easy for us. It's a single variable name containing multiple items. So when looping through a list, the loop variable directly takes each value in the list, one at a time. So here it's having Python loops can iterate directly over list items. The variable n automatically becomes each value in the list sequentially. The output shows each item being accessed and printed, confirming how list iteration works. Using the accumulator pattern with lists allows us to compute things like totals by adding each value during iteration. So iterating through the list is fundamental for data analysis. You can aggregate statistics or even extract specific information efficiently. This is just an example where it's just showing how the sum example is working. So the accumulator pattern, you can notice it. So always set your total variable to 0 before the loop starts. Inside the loop, add each value to it. So you're doing it total plus equals n. This is how you're iterating. What is a while loop? A while loop works differently from a for loop. It continues running as long as condition remains true. So it checks the condition first, then it runs while the condition will be true, and it stops when the condition is false. And we use a while loop when we do not know the number of iteration. In a while loop, we must manually update the variable inside the loop. If we don't, the condition may never change and the loop could run forever. So here we are setting I to 0, right? So while I is less than 5, print I. And then I plus equals 1. So you're totaling it. Yeah. So while I is less than 5, so for the first one, since it's starting from 0, you print 0. And then you increase it by 1. 0 plus 1 plus 1. 1 is less than 5. So you again print 1. Then same goes for 2. Same goes for 3 and 4. So it will do it up until 5. So unlike for loops, while loops require you to manually update the variable I plus equals 1 to avoid infinite looping, or else I will always be set to 0 if you do not manually increment it. So see, the output is showing what I just said. It will print out 0, 1, 2, 3, and 4. The key difference is that for loops are used when the number of iterations is known, while loops are used when the number of iterations depend on a condition. So for this case, our range is known, so we are going to be using for. And this case, we do not know how long or when the battery level will be greater than 20. So unlike for loops, which iterate fixed sets, while loops are ideal for uncertain conditions and continuous monitoring. For in these cases, there are just some cases like user input validation. So repeatedly ask for input until the user provides valid data. For example, enter password. Or keep a program running indefinitely to monitor events, sensors, or network requests. So this is the break statement. The break statement immediately stops the loop, regardless of whether the condition is still true. So it terminates the loop and resumes execution at the next statement. The continue statement works differently. Right now, I'm still going to show you the first code of the break statement. So the break statement terminates the loop entirely. For like numbers 5 through 9 will never be printed. If I is equals 5, then it's break. So 5 till 9 is not going to be printed. The output will just show 0, 1, 2, 3, 4. Now, showing you the continue statement. The continue statement works differently. Instead of stopping the loop, it skips the current iteration and moves to the next one. Here, when the value is 2, the I value is 2, the loop skips printing it and continues with the next value. So it will start from 3 and it was going to skip 2. So if the output is showing that, so it is 0, 1. Then if it's 2, then we skip it. Then we move to 3 and 4. An infinite loop, on the other hand, is a loop that never stops because its conditions always remains true. It requires external force like stopping the program to end. So in this case, for example, using while true creates a loop that runs forever unless we explicitly stop it. Because the condition true never changes, this loop will repeat until the program is forced to stop. Why is this dangerous? It can be dangerous because they can freeze your program, use excessive CPU resources, and even cause overheating. So how do you fix it? To avoid this, we need to ensure there is always a proper stopping condition or use a break statement when needed. So let's look at this mini project where we would build a number guessing game that keeps asking the user for input until the correct number is guessed. We would need to use an infinite loop to keep asking for the input. If the guess is correct, print a success message and use break to stop. So this program uses an infinite loop combined with a break statements to stop once the correct guess is made. So our secret is assigned the number 7. While true, guess is, it's asking for the input, enter number. So we are taking the number as string and converting it into integer. If guess is equals secret, print correct, and then you break it. So when I will put number 7, when I will input number 7, it will be correct. If I input 6, it wouldn't be, or any other number, it wouldn't be. So the break statement is critical here. It stops the infinite loop immediately when the condition is met. For example, now the user is going to put number 3 and 7. And when it's 7, it's going to print correct. We can improve this program by also adding features like counting attempts or giving hints, making it more interactive. For example, we can initialize a counter variable before the loop starts and increment it with each iteration to track user performance. So for example, when you are putting this counter, you can also count how many times it took and intelligent hints. For example, adding conditional statements, if or else if, inside the loop to guide the user by telling him if the guess is too high or too low. Understanding how loops stop and how conditions work is essential for writing correct and reliable programs. Correct logic prevents infinite loops and ensures data integrity. To summarize, loops allow us to automate repetition and write cleaner, more efficient code. Two main types of loop, which are for the definite iteration, while for condition-based iteration. Key concepts include iteration range and loop control, which form the foundation of working with loops. These skills are widely used in areas like data processing, automation, and problem solving in real-world systems. In the next section, we'll move on to functions and learn how to organize code into reusable blocks. To fully understand loops, make sure to practice by solving problems involving counting, searching, and filtering.